I've been in data mining for a while, and I actually don't really have a passion for email or for spam filtering, but I'm interested in it for a number of reasons, one of which I'll get to in a few slides further down. One of the reasons I wanted to give this talk is this sort of, I review a lot of papers, and I've been reviewing papers for spam-oriented conferences and text processing, text classification processes, conferences for a while, and the view of email filtering is, sorry about this, sorry about the fonts, it's kind of like this. It's a little bit primitive. Basically, the view is that you take an email corpus of ham and spam, that is spam and legitimate email, and you either take it from a single site or you take it from something on the web that people have contributed. You go through and you do content extraction and post-processing. You get rid of HTML if you want to. You can parse out headers, do whatever you want to with that. And finally, you put into a bag of words representation here, which is sort of the standard method that people use. And then you experiment with induction algorithms for a while. Support vector machines are the most popular. People have been using random forests and a lot of different ensemble methods. And all the action really happens in the induction algorithm from the research point of view. If you've taken data mining courses or if you've gone to data mining conferences, a lot of the research in the area, a lot of the advances are in terms of the algorithms. And so this is where all the action looks like it is. And so out of the induction algorithm, you get a two-class model of some kind that can discriminate these classes. You run the test set through it, and you do cross-validation or bootstrapping or some sort of validation against the static test set, and you get some great accuracy, about 99% or 99.5%, and you conclude that spam filtering is really easy. In fact, it's pretty easy to get this. Before I criticize this approach, I should say, if you're just getting into data mining or text processing, text classification or information retrieval, it's a lot of fun to do this sort of thing. You can get data sets of spam and legitimate email and stuff like this. It's a very instructive exercise to do, to take these things and try your hand at parsing and pulling things apart. You can ignore as much as you want. You can throw away HTML. You can play with headers if you want. You can basically make the problem as difficult or as easy as you want to. And you throw together the representation, and you can try a bunch of off-the-shelf induction algorithms, and you come out with some pretty good results. And one big advantage of this is that people generally know what spam looks like, and they know how to distinguish spam from ham. And so you get a gratifying classifier that comes out. You can take a look at it and confirm that it actually does pretty well. So this is a lot of fun. It doesn't have too much to do with what really happens in industry. And one of the reasons I wanted to give this talk was not only to sort of clarify what happens in industry, but also to point out that there are really interesting data mining problems that happen in industry. They're just not quite what you see if you read the research papers that are going on. So what makes spam filtering tough? One thing is that the data certainly aren't balanced. There's anywhere between 50 and 90% of spam. It varies from one site to another and one country to another. One of the biggest differences is line number 2, the heterogeneous email stream. People who take single corpora or look at their own email or their own site's email or anything like that, it's really very homogeneous. It's much more than you would believe. Proof points, my employer has thousands of customers all over the world. They range from really small, like community colleges or county systems, to multinational companies. We have to parse Hebrew, Chinese, Japanese, Korean, all kinds of things. We get spam in those languages. We get ham in those languages. We see advertisements for websites all over the world that you wouldn't see coming into your filter, stuff like that. And so it's just much more varied than you would see otherwise. The third point is it's not just text. If you're looking at this as a text classification problem, you focus just on the text and on classifying it. There's a virtually infinite representation space, because what you're seeing is text, is HTML, it's JavaScript. There are attachments. We see sound files, image files, spam coming in through sound files, as a matter of fact. All that kind of thing. Then we have to do certain things with them one way or another. Fourth, the type of errors are different and important. And if you've ever dealt with a spam filter, you probably realize this. There are things called false positives and false negatives, where a false positive is where an important email that you should have gotten has been held up by the spam filter or thrown away completely. And if that's ever happened to you, that's a pretty big deal. It's terribly important, and it really irritates our customers. The false negatives are spam that you see, and that's also irritating, but it tends to be not critical, it's just an annoyance. There are strict performance requirements. We have a service agreement that you probably couldn't imagine. One false positive in 350,000 messages processed, which is just an immensely, vanishingly small amount of errors that you're allowed to make on false positives. Even if you assume that that's 90% of that is spam, that's one false positive in 35,000 negative instances, which is like 0.0008% we're allowed to make. We have extreme processing requirements in that our appliances or our services have to handle about 100 to 200,000 messages per day, so the processing is very extreme. The classifiers have to be very fast. The training has to be very fast. One thing that I'll interject, we get hit very fast. You don't realize if you're looking at a static corpus, we get hit constantly against our spam traps, which I'll talk about in a little while. The attacks come in every half hour, every 15 minutes. We have people on call 24 hours a day. As soon as we see something, our customers see it, and if we don't fix it really fast, our customers send in complaints, and it's taken very seriously, and things have to happen very fast. There's fundamental noise in this problem. There are things I'll talk about, like bulk email, which you get. Bulk is essentially sent out. It kind of looks like spam, but it's stuff that you really want. And bulk looks a lot like spam. It's really sort of a difference of intention. But you don't know that if you're looking at it. A lot of spam looks like ham. There's phishing, which I'll talk about, that looks like ham. These things are really conflated as a data mining problem. They really overlap quite a lot. And you have to go to things that oftentimes aren't available to you, like the intentions, the history of the message, figure it out. Constantly changing. The spam campaigns come and go, and I'll show a slide a little bit further on. They're periodic. They're sort of standard things like mortgage, refinancing your mortgage. I guess there's less of that than there used to be with the economy. The Nigerian widow with $1 million who wants to give it to you, that's a sort of a standard thing that stays around. There are other ones that come and go based on politics, the elections. You get political spam, things like that. There's one final point that I wanted to make, because it's one of my favorites, which is that we have something that few other people have, which are intelligent adaptive adversaries. And I'll talk about this in a few more slides. We don't just have things that are changing a little bit, making things hard for us. We have opponents. We have people out there who see what we're doing. They know how our systems work. They hammer our systems. They inspect them very carefully. They are, we hate to say it, very intelligent and very resourceful, and somewhat evil. And this gives sort of a level to the game that most other people don't see. I'll get into this in a little bit, but I think this is why I got into spam in the first place. I came into it, by the way, from fraud detection, cell phone fraud detection, and I saw the same phenomena that were going on there. You would see people hammering away at the fraud detection systems that we had, and as soon as you changed something, you would see within a couple of days or a week, you'd see people really industriously hitting it against this one vulnerability that you didn't even know it had. And that would just happen over and over again. It's an impressive sight. Things that make spam filtering challenging as well as tough. Again, as I said earlier, we need a fast response. These attacks come in, and we get complaints if we don't handle them almost immediately. Classification process must be transparent. And this is something that, again, the research community, I think, doesn't really appreciate as much, because they tend to work on these black box models. They tend to work on very complicated things that get very high performance. And intelligibility of these models is really sort of a second-class thing anymore. Based on the papers that I've seen, it's not regarded as being terribly important. But as I said, we have analysts who are on call 24 hours a day, and they get called in. They have to look at the errors being made. They have to judge why they're being made, and they have to fix them. Not only understand what the classifier is doing, they have to tweak it and send changes out like immediately. And if they can't understand what the model's doing, that's just a game ender. Finally, there's something that we have that I think like Gmail and Yahoo don't have. There are other places. If you belong to Gmail or Yahoo, I haven't looked at their agreement, but I think they say that they can use your email data for almost anything, as long as they don't release it. They can train on it. Well, we can't do that. We can scan everything, but our customers are like Bank of America and big financial institutions, legal institutions. They send a lot of very sensitive email back and forth, and we scan it for them, but we can't send it back. They're just very sensitive about that. If they catch errors in our system, then we obviously, when they report those, we can take a look at them. But in general, we're not allowed to otherwise. Now I want to, this is a digression on what I called adversarial classification or adversarial learning. It's been around as a subfield of data mining. It's been around for about about 5 years by now. And it's one of my favorites. One way of viewing data mining environments these days is by these 3 classes that I've drawn here. The first is kind of standard data mining, where you have a set of data. It's sort of static or fixed, and you take it and you analyze it. You come up with a model, and maybe you iterate that. But the data doesn't change, really. It stays there, and you produce your model, and that's kind of it. The second one is dynamic, where you have concept drift. We have non-stationary entities like web search queries, things like that. There are a lot of other time-varying things where you have that as well, where the concepts change from one time to another, and you have to track them all, and you have to see when one is changing. You have to adjust topic models and stuff like that, and that's definitely challenging. It's more difficult. But the third one is what I call this adversarial, where you not only have a changing environment, but you have an adversary who's actually in the feedback loop. You have an environment that's in the feedback loop with the adversary. And you're putting in a filter. You're trying to block access to a resource. The other person's trying to get at it. You're changing your filter. The adversary is trying new ways. You're both sort of jockeying. It's a big arms race that you go through. And this makes things very difficult. One of the reasons I'm interested in this is that at the extreme end of this, you get into economics and game theory and complex systems theory, which is sort of one of my interests. And you get into chaotic dynamics that happen when these things are playing games against each other. And the other point I want to make on adversarial domains before I go on is that actually these days, I see them almost everywhere. It's the advent of the internet. I've listed a few of the domains here. As I used to be involved in cell phone fraud and fraud detection, credit card fraud. These are old things where credit card fraud detection has been around for a very long time. And that it's always been the case that people look for the fraud, and the fraudsters try to hammer at what they're doing. With the internet, there's more and more stuff being online. There's more resources, more assets that are being put online. Many more people that can access it interactively. There are automated filters, as we all are aware, because we're data mining people. Data mining systems that are being set up to filter these things or detect them, and other systems on the other side that are trying to attack them. And so more and more of these adversarial domains are showing up. In general, if you have a valuable asset and intelligent agents, and you have a large enough playing field, then you have an arms race. And these are some of the domains. I'll just go through them very quickly that are interesting. The click fraud, I haven't talked to any Google people or search engine people, but I know they worry about this a lot, detecting click fraud and trying to prevent it. Blog spam, tweet spam, spam in just about any form of communication you can think of. There's advertising and ad blocking, where the blockers are getting better and the advertisers are getting better at getting around them. I don't know that much about the CAPTCHAs and CAPTCHA technology, but I think we're on like the 3rd generation or so of those things, where they had basic CAPTCHAs and then they got more complicated and people figured out how to defeat those, and it goes back and forth, and it just keeps going. So, and spam is one of the more notorious, one of the best known examples of this thing. But so are the viruses and antivirus products. I think all of you, if you have home PCs, you know how often new viruses come along and you have to update your definitions. What is it, like every other day these days? And so it's just really constant. And so these are everywhere. Once you start looking for them, you'll notice them. So that's my pitch on adversarial classification. Before I go on to talk about email, then, I want to discuss a few of the things, a few basic definitions. We have to identify a couple different kinds of email. I'll generally call it spam throughout this talk, but one of them is bulk email, which is, strictly speaking, it's when somebody sends email to you that you've agreed to receive. It's sent out in bulk. A lot of the difference between bulk and spam isn't really clear. Like I'm sure many of you are, if you bought something or corresponded with a website, there's a little checkbox at the bottom that says, uncheck this if you don't want to receive our email. And a lot of people forget to do that, and suddenly they're signed up to get hammered over and over again with these advertisements. Strictly speaking, that's bulk email. And in many cases, we can't just block it. We get complaints actually one way or the other about blocking that stuff. Spam, I think, is obvious. Viruses, people still send viruses via email these days. There are two kinds here. One is just by attachments, where somebody sends you an executable file, and if you're dumb enough to click on it, you get infected. The other thing is called a drive-by download, which is where I have an example of it further on, where somebody sends you a web page and it inadvertently, or rather through an action of yours, that ends up downloading a virus that gets stuck on your machine. It isn't part of the email message, but it gets done. And finally, there's phishing, which is when the sender represents a legitimate sender and pretends that they're generally somebody from a legitimate institution, like a financial institution or eBay, and they try to get you to give up your account credentials or your bank account, whatever, anything sensitive like that. But we categorize all of these, and we have different classifiers actually for them. But in this talk, I'll call them all spam. There's some basic terminology that's used that in order to talk about the errors that we make. Legitimate email is commonly called ham, just for historical reasons, and the bad stuff is called spam. The ham is called a negative class. Negative has sort of the opposite from intuitive meaning, where it's not a threat. It's not something you should alarm on. It's innocuous. Whereas the spam is the positive class. It creates the alarm. And so that's the positive class. The errors that we can make then are the false positives, which are false alarms. They're legitimate email coming through our filters that we catch and we shouldn't. And those are declared in one class. The false negatives are, again, spam that simply got through. It's important to know where we get our training data from this, because it implicates our whole process for how our operations work. We have an historical set of data of ham and spam going back many years that we use. It's sort of a static base upon that. We have things that are called spam traps, and every spam filtering company has these things. They're basically big mail agents, mail machines that sit out on the internet. They're publicly known, but the fact that they're spam traps is confidential, meaning that it'll be xyzcorporation.com, and spammers will send to that. Their name is advertised everywhere, but they will not know, and we keep very carefully guarded the secret that that's a spam trap. And so all the email that we get into spam traps is regarded as spam. This is sort of a pure feed that we get coming in. We have on the order of dozens to hundreds of the spam traps. We also have things called honey points, which are special, sort of usually defunct email addresses on other people's legitimate domains that get nothing but spam. And we use those as a secondary source because their machines, their domains see email that we don't see, and so we can use that. And again, false positives and false negatives we get from the customers when they make complaints. This is a dashboard diagram from our spam trap. As you can see on the left-hand side, this is a time series of how well we do. Again, so these spam traps are supposed to get nothing but spam, and they come into our filters, we score them immediately, and we record how well, a lot of statistics on how well we're doing. And so ideally, we should be at 100% all the time. As you can see, this is, you can't read that, but that's 99% at the bottom and 100% at the top. So this is the very top band. And you can see the heavy line is the moving average. You can see little dips that go off of there, and those are attacks that we get on the spam traps. I forget what the threshold is, but if we get one of these typical size dips, we tend to worry. And I think if it gets below about 99%, then people's phones start going off in the middle of the night, and they rush and try to fix things. And so on the right-hand side, you see some of the top sending countries and machines. This is some of the subnets in Russia that are sending currently the most spam at that time. So it's the monitoring of the spam traps, this big positive class, yeah, that determines what we do. And I should have said, this is a data mining audience, and so I really didn't want to turn into an email tutorial or a spam tutorial, but I wanted to talk basically about what happens when you get email, because it does inform what we do. It does affect it. I'm sorry.
Could you say a little bit more about the training data? How large are those data sets, and are they really, does that data sort of change over time so that the old data is not really that relevant anymore?
That's a good question. So The ham tends not to change over time very much. We have large historic databases, I would say on the order of 1 million messages or so. The spam, as I'll get to in a little bit, there's a large amount of it that doesn't change very much or only changes periodically. There's some sort of, at the top, these attacks that we see that we've never seen before. And so those are the ones that we have to pay attention to, and I'll discuss that process. So this is the basic protocol. This is the SMTP protocol, for those of you who've heard of it. Basically, there's the inbound sender on the left, and the filter agent that's receiving this stuff on the right-hand side. The inbound sender makes a connection and says, hello, I'm machine XYZ, sample.org, and here's my, and you get the IP along with the connection, and we say hello, and then the sender says, I am such and such. They give you an email address, may or may not be right, but if you get errors in the transmission, that's the one you can theoretically use to send complaints back to. And we say, okay. Then it gives us a bunch of recipients who are supposed to receive this message, and we take them in and say, okay. Then we say, okay, send the text. Then they send this big blob there at the bottom, which is the text message that we get. And then we say, okay, and that's it. Now, what did we get? In that exchange, we got basically the machine name and the IP address. The machine name, hopefully the two match, and we can do a test against these to make sure they do match. And if they don't, that's an interesting piece of evidence right there. There's a return address, which again is probably forged if it's spam. There are the recipients, which can't be forged because these are the things that the people that the spammers want to hit. One thing that some researchers, so after that we get the mail body there at the bottom, which is just a big hunk of text. And something that people looking at this problem don't understand is that's a big hunk of text. And there's nothing sacred about it. It's not signed, it's not certified, it's not, there's nothing, it can send you anything really. Any of that can be forged and often is. In particular, the first part of it, you can see these received lines if you've stared at raw source messages for a while. The received lines are a record of who got the message and when, which machines got it. It's one link at a time, the sequence of links that it went through. And on a valid email message, this is all valid and reasonable. It often gets spoofed. Phishers, in particular, love to hack this stuff. They want to look like they're coming from Bank of America or some big financial institution, and they're really some little DHCP server on an ISP in the middle of Russia somewhere. They try to fake these things to make, as best they can, to make it look like they're really coming from the big financial institution, hitting the backbone. They don't want to look like they're just some dial-up guy coming from the side. After that, we get the sender and recipient, which again, hopefully is accurate. The from line could be entirely wrong. And followed by that, we get what's called the payload, which is the text, HTML, whatever else, including attachments, which can be basically anything that can be MIME encoded, but it's all text. But again, you can, again, about the falsification of these received lines, there's some people who have done analysis of these things, and you can do analysis of the received lines, and you can come up with interesting facts. If they don't match, or if there's some weird anomaly, that's good evidence. But you can't take them at face value, and you can't construct network graphs of where you get all this email from. That just doesn't always hold together. Well, sorry about the fonts. So this is the overall process that we go through in the filtering, given an inbound email connection. Basically, it's a staged filtering process where we go from the fast, cheap, reliable stuff into the more expensive and more expensive and more expensive, steadily components that we check on. And at any point, a given component can reject it entirely, or it can pass it along to the next stage. And so the first thing we do is the so-called IP connection scoring on the left-hand side. And that basically says, who's sending us this email? What do we know about them? Is this some compromised host? Is this some guy who just got on a day ago? And we have a system for that I'll talk about. Next thing we do is go through the email message and strip out all the URLs. We look at the URLs, which is an important thing to do because it's basically how the spammer is advertising. It's pointers back to what the spammer wants you to do. And that goes through what's called domain reputation and scoring, where we keep track of the reputations of all these URLs, all these domains, and we can provide a very fast analysis of what where they go to and whether they should be trusted. And if they're not, we reject them. Then we go through header extraction. And finally, about the fourth or fifth step is actually the content parsing, which is what most of the data mining researchers actually focus on, which is taking apart the words and things like that, even the HTML, in more detail. For us, it's pretty far down because it's very expensive. Pulling apart the words itself is more expensive than the other steps. And once you get into regular expressions, if you're familiar with Spam Assassin or any of those regular expression-based engines, you start running regular expressions on email, and it gets really expensive. You can bog down pretty fast. And so you really want to push that off as long as you possibly can. And if it gets past the content scoring, then you go and deliver it. So what's this first step in more detail? This is the reputation model, where, again, you have the IP, the sender address. Let me clarify. This is the person who handed you the mail. This isn't the from person. When somebody sends you an email, it can go through several different steps, or just one step. The sender is the one that you immediately got the email from. Keep in mind what I said before on the headers. The only one you can really trust in this whole game is who sent it to you. You know their IP address because they made the connection. Everything they might have thrown into the message before that can be complete rubbish, and you can't trust it at all. So what you're looking at is the reputation of the guy who just sent it to you. And we look at several different things. We look at the other, as I said, we have this network of spam traps, and they're all getting email at the same time. Our customers are getting email. We're keeping records of all this stuff coming in. And we want to know who's getting email from this guy. This IP is sending us stuff. What is it? How long has he been around? How much email? Statistically, how much of it is spam? If it looks like this guy is suddenly on the network spewing a lot of stuff, then that's a big red flag. We also look at external factors. How long has the IP been around? How long has it been registered? Is it a DHCP host? Which means usually you're familiar with botnets, where a virus takes over a machine, and that machine can then be used to send out spam. Those little machines usually aren't used as big email servers. And if you get some little machine off, in a small town and it's sending you email from the Bank of America, that's kind of a red flag. We look at who it's registered to. We quantify all this stuff from the internal and external factors, and we put it through a classifier. And we basically come up with a score based on the IP reputation. Should this email message be trusted or not? In fact, we have, yeah. Oh, you mean you sending mail or you receiving mail?
I'm sending mail to somebody else. It used to be that sending through some providers like GoDaddy would get me into trouble if the mail wouldn't go through.
And that's probably why, because they didn't.
Has a bad reputation.
Oh, okay. Well, that may explain it. So in general, a lot of ISPs these days have a central mail host, and you can only send out through that mail host. You connect to them, and they make the connections for you. If you try to connect to some other host as little DHCP host, you often get rejected.
That server, and not so much the poor individual trying to send mail through it.
I'm sorry.
Is this scoring like GoDaddy instead of me?
It's scoring the server that's sending right to them. It's not scoring you. It's scoring your ISP's mail server. Yeah. It'll pass this test. It'll be sent to your ISP, and as far as we're concerned, your ISP looks good. It's reputable, and so it won't trigger this thing. It'll send it on. Okay, but yes, because your ISP is reputable. It's the bottom line. Okay.
Unless they have a habit of forwarding spam a lot.
No, even that. No. That doesn't come into this. I mean,
I have 5 different email addresses. One from my college, one from ACM, one from this, and I sent them all to forward them to one place.
okay.
You're defending my one place.
I'm not condemning your one place. Is the difference?
You're defending your company.
Oh, you're saying I'm filtering for you. Okay.
Right. Okay. So, but all of my mail is going to coming from all of these forwarders, right? And therefore, you're going to consider
I will not condemn them on the basis of IP reputation.
Whereas
Correct.
knowing that they really are legit, you can go one step back.
Okay, this is getting a little beside the point. One of the reasons is I can't go one step back. I'd have to trust you as to who is upstream of you, and I don't want to trust that. So, any other questions before I'm? Sorry. I should point out that the classifier here has actually several actions. You can accept a connection, which means go ahead, give me your mail, and pass it further down. Reject basically says, I don't trust you, go away. It terminates the connection immediately. There's a throttle thing, which is where if we start getting spam from a given source and it's mixed in with legitimate email, we can decide, well, we're going to talk to you, but only a few messages per minute. We'll limit you to I don't know, like 5 or 10 connections per minute or something like that. I forget what the rates are. And finally, there's one called discard, which is like reject, but it's sort of like, yeah, give me your email, and then once the guy disconnects, we throw it on the floor. It's a way of accepting email from a spammer without giving them the information that we're not taking it, that we're tossing it. And so we keep the reputation of all these IPs, and they're updated quickly, and they're shared among all of our customer sites. So the next step, if it goes past the IP, is to go into the domain scoring, the URL scoring, which is, as I said, these are the URLs in the email messages. And this is very important because if you think about spamming, it's possible to get a message through, but if you just say, hey, visit, myaviagra.com, most people won't bother with that. They'll only bother with it if they can click on it. They won't bother with, an audio file or anything. It has to be very convenient for them. Spammers have discovered that unless there's something that people can immediately click on, their rate just goes to 0. And so they have to have URLs somehow that identify what it is that they want you to do, where they want you to go. And so we extract the URLs, and we have a similar reputation system with a little bit different criteria. We look at people who registered the domain, how recently has it been around, who's the name server. Occasionally there are name servers that have registered multiple spammy. They go through one spammy domain after another because they get condemned one after another. But we can look up to the name server level and say, and proactively condemn other things that they've created before they even send out spam from them. And so we maintain, again, a reputation. We have a classifier that quantifies all this stuff and produces classifications on the URLs. And further along, if we notice that people are sending lots of spam, then that feeds up in a loop to the URL scoring and starts condemning the URLs. This is well known by the spammers, by the way. And so instead of, in the past, they would have domains called like, mycheapcanadianmeds.com, which is probably actually a real domain name. And they would advertise that. And they discovered, of course, that it's very easy for us just to condemn that whole domain, no matter what URLs, what pages on that machine they put it. And so what they do is they use public resources like Google Groups and various public posting sites. I think blogs might even be used for this as well, where they set up a spammy page or something with the URLs, and they'll post a pointer to that. And they know that we won't condemn all of Google Groups altogether, so we have to do it one page at a time, one very specific page. Bitly and the various URL redirectors, there's a whole bunch of them these days. Those get very commonly used for this as well. Spammers, I think, don't even bother advertising their raw domains anymore. They go through these redirectors because they know we can't nail all of them.
Do you expand those?
I'm sorry?
Do you expand those URL shorteners?
The first thing we do is condemn. If we discover it is spam, we condemn the entire unique Bitly thing. We don't. What I'm saying here is that we don't condemn Bitly itself. We don't condemn that entire domain, because that would be foolish. But we do condemn the specific thing. And we have projects underway to actually go off and see whether that's spammy, or see what it redirects to, although that's a little bit dicier.
Work on business partnerships with some of those to unpack that or cooperation with them?
I honestly don't know. As far as I know, we don't. That might be a good idea. Content scoring is, yeah. I'm sorry, I can barely hear you. Yeah. Simply because it may go through multiple levels of indirection. as far as I know. And I've heard of various other things. I'm not on that team, but this is what I've heard. Finally, there's the content scoring, which is probably the most well-known thing. What we have is a set of regular expressions that are based, well, we use Spam Assassin as sort of a base. It's a public domain regular expression-based engine and large set of rules that matches against spam. We use their rules. It's not updated very often, which is one of the reasons it's not really great. Then we have a set of rules on top of that. We have a thing called a lexicon, which contains over 1 million entries, which are phrases and terms and rules, as illustrated here on the right. Lexicon is a bit of a misnomer. It's not just like a dictionary. It's really, again, these words and phrases, and they can link together. We can have conjunctive and disjunctive terms, so they really fire together in a lattice form. And it comes up to a set of entities here that the oval is around. And that's what we learn on. This represents the representation that we learn on from the lexicon. We use a very simple concept learner for this, a modified form of logistic regression, which basically assigns a weight to these things independently. You're probably all familiar with logistic regression since it goes back decades and decades by now. It's very straightforward. My next slide talks about why we do that. In use, it produces a score between 0 and 100. So a spam content, we get between 0 and 100. We tend to condemn the stuff that's anything above 98, I believe. Below, I'm sorry, above 50. 98's another threshold. Sorry. So one of the questions I always get is, why do we use such a very, sorry, go ahead. Email headers are used. What are they? They're used in regular expression matching. They're not analyzed on the first pass. The Spam Assassin rules actually do a lot of header analysis and produce digested versions of things that are there. Our lexicon looks into headers like subject. It looks into a few of the headers, but it doesn't go into the deeply technical things like received from stuff. Yeah. The question is whether we use specialized hardware for regular expression matching. No. We have our own hardware. I don't think, obviously it's matched to what we do, but I don't think specifically matched to regular expression matching. Good question. I'll get to that in a few more slides. So I wanted to just say briefly about, since I get this question a lot, about why we use such a simple approach. Logistic regression, some of you probably know, basically just assigns weights to these terms, positive and negative weights. If they're positive, it means they in essence, they correlate with spam. They regress highly against spam. There's several reasons. One, well, the best reason that I can give is that there's really no advantage to using more sophisticated methods. We've experimented with support vector machines and forests and a few more things like that, ensemble methods, and we really don't see much of an improvement over that. And so logistic regression, which weights the individual terms, gives us about all the performance that we see. It gives us very acceptable performance. And the reason for this is that actually our representation form is fairly sophisticated because it's not individual terms. It's these things that can be combined together in rules and phrases. And so it incorporates a lot of the conditional probabilities, a lot of the dependencies among features in the representation itself. And I'll talk about that, how we manage that a little bit later on. And again, as I talked about earlier, we have human analysts who have to look at these things and look at the decisions made and have to fix things. They have to look at the individual decisions of the model and the components of the model and understand them. A complex thing like a set of support vectors, I'm not sure they could really do that with. Whereas if they look at a message and a set of lexicon terms and the weights associated with that, they can see what the score adds up to, and they can see pretty quickly if there's something really egregiously wrong in that score that should be changed. Usually they go in and they make a change that has to exist for a few hours before the training model can catch up. There's also the additional requirement for space and time efficiency, where, again, the machines that do the filtering are under a lot of time pressure. They have to process these things very quickly, and so we need very fast models. And the training has to be reasonably fast. Well, it has to run overnight, and it's not clear that some of the parsing plus the training actually will do that.
What's a ballpark of the number of features you use going into the regression? Is it dozens, hundreds, thousands?
1.3 million. So it's a sizable thing. And the problem, whenever we change the representation, which I'll get to, we have to redo the parsing of the entire corpus, which is a big process in and of itself.
So is that 1.3 million going into the parsing, or what goes into the regression?
1.3, about 1.3 million goes into the regression itself. I'm not going to say anything about this. It's an interesting slide, but. Okay, so somebody asked how often do we retrain our models, and the answer is shown here. We have, every 24 hours, we have what's called a major cycle, which is where we reparse the entire corpus and everything that's ever been put into it based on the current representation. We consolidate the lexicon, we retrain the models, and we send the lexicon and the new weights back out to all of our customer sites. It gets pushed pretty fast. And so this happens every 24-hour cycles very regularly. The problem is, as I said earlier, we get hit constantly, like every minutes, every minute, every 15 minutes or so. We have to be able to respond to that. We can't wait for 24-hour cycles to upgrade our customer sites. That's just way too long. And so we have what's called a fast attack response, which is a separate component that comes in and looks at attacks and basically distills them into terms that are predictive and adds them to the lexicon and updates very quickly. So this.
Your training phase with 1.3 million features, you might essentially be finding 1.3 million optimum weights.
It's constrained to finish, well, the number of cycles is constrained, and it tends to take about an hour and a half, 2 hours.
Parallelize it?
Somewhat, yeah. So this is the fast attack learning and response, and as far as I'm concerned, this is one of the more interesting, from a data mining perspective, one of the more interesting aspects of the spam detection. So again, on the left is a portion of the graph that I showed you earlier, the performance of the spam trap, where we're coming in and we're evaluating every single message that comes in, and we're looking for failures. We're looking for a dip in the true positive response rate. So every 15 minutes, we have a component that goes out and sees what's missed by the filter and whether that's a substantial amount. And if it is, it assumes that it's an incoming attack. It extracts the documents, the email messages, the raw messages from the spam trap. It parses them, not according to the lexicon, but a very basic textual parse. It sets aside the email addresses, the URLs, and various components. It then goes through a clustering process, which is actually a modified form of, I didn't want to get into the details of this, but a modified hierarchical clustering process where it tries to identify individual attacks of the components of separate attacks. Once it gets the clusters, it tries to find, it consults this lexicon, this is step 5, consults the lexicon of the terms that we already match, that we already know about, and looks at the clusters and tries to identify characteristic terms in these attacks that can be used as part of the representation. And based on that, it comes up with a set of candidates. It goes through a post-processing step to make sure it's not interfering with anything, and then it pushes it back out to the lexicon. And this all happens on the order of the whole process in about 15 minutes. So once every 15 minutes, this gets kicked in, and it pushes out a new lexicon change to the sites. Payload size, you mean the size of things that are?
Right, when you push the updates, is that like in megabytes or kilobytes?
For the lexicon and weight, lexicon is probably in the order of kilobytes. The major changes are in megabytes, at least. So one thing I wanted to make a comment about this at the first line. When our filters fail, it's not generally a failure of the model itself, meaning it's not really that the model has weights that weren't set correctly. So it really doesn't make sense for us to go back and retrain the model anew using the old representation. It's probably the case that the representation was wrong, that there's a new attack, the spammers are using some kind of new thing, and we just fundamentally didn't capture it at all. And so this process sort of bypasses that and goes to the representation level and shifts the representation, which then gets fed back into the lexicon. This is another reason why we can get away with something like logistic regression, because we're accepting that there's going to be a lot of representation adjustment going on at the bottom here.
You worry much about stability versus plasticity, like adapting too much and then things that you used to be good at preventing because you adapted to what's happening in this 15 minutes, now you're opening up doors to what used to be stopped?
That's a good question. We do basic checks against the lexicon to make sure that we're not doing anything egregiously bad, that we're catching things that we missed. And so you can see that as sort of a, well, I hate to call it a patch, but that gets put back into the lexicon. The training will take care of any further errors, at least we hope. That's a hand-waving answer. But,
If they didn't get selected, you put it back in.
I'm sorry?
Like existing suppression lists, like known bad phrases. If they didn't get selected in this generation of the model, if they were used in previous generations, you might leave it in there then?
Usually they're not left in, but they'll be rediscovered based on a new attack. They'll be regenerated. So one of the points I wanted to make is that since the data mining community, as far as spam goes, leans heavily on text models and text classification, I wanted to talk about why they're not good enough. And everybody who works in spam has sort of a set of sort of a hall of fame of what spammers do. They have a list of really bad things that spammers have done to get past their filters. And so these are a few examples. One is intentional misspellings. I'm sure you've seen this if you've looked at any of your spam. Viagra gets misspelled in a zillion different ways. You might say, well, why don't we kill file Viagra? Why don't we make that a spammy term? Well, we can't, because a lot of people discuss Viagra legitimately. One of our customers is in fact Pfizer, which makes Viagra, and they don't want they don't want false positives out of that. People misspell words all the time. As you can see, a lot of legitimate email misspells it. One word that I heard, Cialis, that looks like a common, Cialis is an erectile dysfunction medication, which is a common class of things that are advertised. Cialis, it turns out, you might think that's a misspelling because you hardly ever see it, but it turns out that's the root, I'm just amused by this, it's the root designation for a Rome to Lyon, France abbreviation. CIA is the Rome airport, LYS is the Lyon airport. Travel agents in Europe that we didn't know about start using this. They start sending it out in their emails. Suddenly we get false positives because this thing we could never imagine ends up getting filtered out. So there's inherent noise and overlap in the classes here. There's some level of noise that we just will never be able to solve. It might if you could assume that there were other, it's a matter of feature dependencies, feature interactions. You could assume there are other features in it in the representation that would fire together to lift it above the spam threshold weight and keep it below it for the travel agent, then you could do that. I'm not sure you could do that reliably enough. And you wouldn't want to go through several iterations of this anyway, while the travel agent's sitting there getting false positives day after day after day, and their clients are getting mad because they're never seeing their itineraries. So that's a little bit risky. In general, for things like this, we don't kill file the whole thing. I would say that as long as it's in our corpus, so things get aged off of our corpus, and as long as they're not aged off, they will show up again. In general, it isn't true. There's a good reason to age things off, because there are spam campaigns that we just never see anymore. There are things back when the Iraq War started, for example, that we saw a lot of, and those have gone away. And so there is a good reason to age things out, if that answers your question. They're along with the classifiers. They go into a queue that basically, I won't tell you for how long, but basically they go into a time delay. After a certain amount of time, they get picked up again, and they're allowed to send again. So they come off the bad list, so to speak. The difference is often, as I said, intention, the difference between bulk mail and spam. We get a lot of people who get spam, it's just being emailed that they don't want or don't remember getting, and we really have no way, even they have no way of knowing whether it was intentional or not. And so there's too much conflict in that regard. Yeah. Look, you can ban it for your site if it's really that irritating. It looks like bulk mail to us. You know, ban it if you have to. We're not going to ban it across all of our customers because it's, we call it bulk, and you can call it something else, but we won't. Yeah. So the service level agreement that I showed you earlier is on the false positives, not on the false negatives. If they say you block this, don't block it, then we won't block it. I mean, if they'll demand that a false positive be released, that's fine.
Giving them all of the dubious stuff gets through.
I'm sorry?
So you end up
I didn't
saying
follow that.
in order to avoid the false positives, all the dubious stuff, all the stuff that's ambiguous, ends up getting through.
They can do site-wide, if they insist, they can do their own site-wide stuff. Their own site-specific rules they can impose, which is usually what it comes down to. If it gets into an argument, we don't get to that.
Do you make any attempt to represent or reason about intention? You said that's important, but what do you do about it?
We don't really do anything about it. If somebody inadvertently sign up for email, what do you do? You can argue that the case, but if they want it blocked, they get it blocked. Is the bottom line. I should say one anecdote to throw into this. There are some political parties that are actually notorious. There are a lot of places that will say, just click here to unsubscribe. What we got were political parties sending out election information that never respected their unsubscribe requests. And so they would send this stuff over and over, and nobody ever got off their lists. And eventually they would say, you know, this is spam, we just really don't want it, this isn't bulk anymore, and condemn it. And we had to deal with that stuff. So there's some really tough gray areas. Yeah. We allow them to do it on a site-by-site basis. We don't do it on a user basis. There are various reasons why that would be. It's difficult to have individual users maintain their own filters that way because you have to provide an interface for them. You have to, what if they condemn the wrong stuff and start complaining to you about filters that they created? Things like that. For various reasons, we just don't do it. So this is a common example. This is why text processing doesn't work. If you can read it, this is Cialis and Viagra spelled out in big ASCII letters. As a language model, there's nothing you can do with this. These are nonsense letters. You can try to memorize the nonsense strings. They'll change. You can memorize white space. They'll change. You can characterize, nonsense to white space. You can do all kinds of things, but the spammers can get around it so easily. There's nothing you can do. With this, you pretty much rely on them having some kind of a URL or some other indicator, generally a URL, that leads back that can be condemned.
Do you have like percentages of things filtered out by different stages that you mentioned?
Yeah, we should. I don't have that readily available. One of the reasons is that it changes. It's a dynamic system, and all the components change, and what each one of them sees changes all the time. It's really not easy. I will say the IP and the domain reputation filters out about 60%. So only about 40% makes it through to the content scanning. I just noticed there's a monitor above me. This is another example which I think is ingenious. You probably can't read it very closely, but there's basically a bunch of nonsense words here in the first one. The bottom thing is a rendering of it. This thing came along with a CSS file, a CSS sheet that determined how it would be rendered. And it basically renders the first letter of each of the nonsense words. And so if you try to characterize these nonsense words, you'll get nothing. But once you render this, it looks at the individual letters, and you get the magic advertisement at the bottom. And we do some things with CSS and some things with indivisible tricks that they do, but we can't catch everything. This is another example, again, not even alphanumerics that they use here. Viagra 911. They either stick a URL into this, which people can use, or they depend upon you typing this into your web browser, one way or another. This is my final example is an egregious one that we got about a month ago. I forget what the code name for this was. This caused everyone headaches, including us. This is the source here on the left. You probably can't see it, but it's just a bunch of HTML. There's nothing interesting in it at all. You render it, you get the thing on the right-hand side, which is like a screen capture or a source capture of the New York Times headlines for one day. There's nothing unusual in the URLs. They're all New York Times stuff and New York Times advertisers. There's nothing in the text. It's straight news. There's nothing at all unusual except at the very bottom in red here is a bunch of stuff which is JavaScript, which you wouldn't notice otherwise. And there's nothing even in it that's particularly interesting or unusual. I don't know if you can read this. There's a string here that's just, it's pure gibberish. What the JavaScript does is each of the letters is off by one ASCII value. The script goes along and switches it up, and you get the thing on this right-hand side, which is what it basically rewrites your document, reloads it, goes and fetches this thing, and it's called a drive-by download. You're infected as soon as this happens. And there's no content at all we can condemn here. There are no URLs. They've specifically made it so there's nothing, no URLs showing here that we can condemn. We're down to JavaScript. This keeps us awake at night. From a computer science perspective, if you think about this, trying to figure out whether that thing's malicious is like the halting problem. You can memorize the individual strings. They'll go on to something more sophisticated. They'll go off by 2. They'll go off to more advanced strings. They'll go off to complete fragments. It's impossible to decide in general whether this thing is going to produce anything that's ultimately malicious or not. We sort of depend on, to some extent, the laziness of spammers. They don't tend to do anything more than they have to. And we tend not to do any more. I should say, back when I had the adversarial domains thing, one of the characteristics of an arms race, which is what this is that neither side has to be optimal. Either side has to really solve its problem perfectly or even terribly well. They just have to be one step ahead of the opponent. We have to be one step ahead of the spammers who do this kind of stuff. We don't have to come up with the ultimate JavaScript classification method. And this is from I guess I want to talk about this. The last thing I want to talk about is, so that covers content scanning and all the basic things that we do. This is sort of on the horizon. People don't normally think of spam and email as being a mode of social networking, but it is, of course, a form of it, where people send email back and forth, and you have links. You have links between spammers, it turns out, links between machines, and all that stuff. Recently, we've been investigating link mining and network analysis to identify anomalous, low-probability links. There's been some work done on this between recipients. And it's been fairly promising, actually, in that you can spoof somebody, and that's done all the time. If you look at incoming spam, people pretend they're you all the time, or people at your domain. What you can't reliably spoof is your connections to other people. You can steal an address book and get some of that, but even that's not perfect. And so you can look at things like patterns of legitimate email sending and receiving. The traffic goes back and forth. You can look at things that spammers are connected to. You can look at addresses that they should never be hit as like a conditional random field, where if there's one address that gets nothing but spam and suddenly you see a new incoming email address trying to send to that, you can reverse it and assign a high probability to that incoming message, that attempted link as being spam. And of course, you can do things like, as we do, where you look at the IPs and look at corresponding name servers. How are different things associated with spam, the IPs sending out the spam, or the domains that advertise it, how are they linked together, who registers them, things like that. You can look sort of behind the scenes at these networks and exploit some link mining techniques to improve spam classification. And that's the end of my presentation. Are there any